Question number 5. You have the graph alternating current AC through the resistor 220 ohm. So calculate the RMS current through the resistor. So you look at the graph here. So this is a maximum current. Actually, this is equal to I naught. Yeah, to calculate the RMS current. So IRMS, you can relate to the I naught is equal to square root 2. And the I naught here is equal to 0.006 divided by square root 2. So RMS is equal to 40 exponent minus 3 ampere. Okay, so we go to the next questions. Number 2, calculate the peak voltage. Our peak voltage here is a V naught. So for the V naught, you can relate to the I naught is times R. So the I naught is come from the graph here, 0.06. So meaning, so V naught here is equal to 0.06 and the R is a 220 ohm. Now you can find the value of the V naught is equal to 13.2 volt. And number 3, state the equation voltage across the resistor. So this is the sinusoidal graph. We need the equations for the, let's say you have this is graph V versus T, right? It's the same graph. So we have a V is equal to V naught sine omega T. This is for the graph here. So what is the V naught? So V naught is come from the answer number 2, right? So I write the equation here. So V is equal to V naught is a 13.2 volt, and the sine. So what is the value of the omega? Right. So to calculate the omega, so you can find the use equations. The omega is equal to 2 pi f, right? So what is the frequency? So if you look at the information given by the questions, no frequency, but if you look at the graph here, so this is a one complex cycle here. This is a 40 millisecond. This is 40 millisecond. So as we know, the T is equal to 1 over frequency f. So to calculate the f is 1 over time or period T. This is 40 minus 3. So the frequency here is equal to 1. So just put the value of the frequency here. So you can use the frequency here. So you have a 2 pi f is equal to 1 over 1 over the f here is a 1 over 40 exponent, okay, millisecond, right? This is a millisecond. This minus 3. So the omega, if you use the calculator here, omega is equal to 157.1 sorry 157.1. So you can use the value of the omega here to the equation here. This is a 157.1, right? This omega, and this is T, right? So this is value of the or answer the equation for the number 3. So number 4, calculate average power dissipate. So power dissipate, so right here then power dissipate equation, you can use the P is equal to half I naught square R. Because why use the I naught square R? Because I naught is come from the graph 006 and the R given by the equation 220, right? So you can use the calculator here. The P of power, average power dissipate is equal to 0.4 watt, right? Continue number 5b, a sinusoidal equation Vt V20 sine 50 pi T apply to the RLC circuit. You have a RLC circuit. This is value of R, L, and C. Calculate impedance. So to calculate the impedance, Z, this is number 1. So you can use the equation R square plus XLC minus XC square. Right? So just the value of the R 6670, XL you can use the 2 pi FL, XC 1 over 2 pi FC. So you just use the calculator here and write the final answer. Z is equal to 676.87 ohm. Right, straightforward. And the phase angle also you can use the equation. This is number 2. For the phase angle you can use the tangent psi is equal to XL minus XC divided by R. So straightforward from the value, R is a 760, XC and XL you can use the equation here. So use the calculator and put the value for the equation here, so you can find the phase angle theta, or psi is equal to minus x.17 degree. So this is the number 2, 5b2. And we go to the next questions. The frequency of AC source is adjusted until the draw maximum current. So what is the meaning of the statement here is when the maximum current, meaning XL is equal to XC, or during here we have a, we call it resonant frequency, or we have the value of F0, right? So at the process here we have a maximum current, or I is a maximum. So at the situation here also, Z is equal to R, or impedance is equal to R, because of XL is equal to XC. So calculate the frequency of the AC source at this instance. So because at during the this process we have a XL is equal to XC, so meaning you have a XL is equal to 2 pi FL and XC is equal to 1 over 2 pi FC. So now you can find the value of the F here. So F here is equal to 1 over 2 pi square root LC. Right? So the F here is already, this is a F0, or resonant frequency. So you can use the put the value of the L and the C here, so you can find the value of frequency here is 46.4 Hertz. Right? So when the AC source is adjusted, thus is change the power dissipates, the answer is a no change. Why is no change? Because of frequency is not frequency, you cannot relate to the resistor R, because at the situation here XL is equal to XC. Because XL, yes, you can relate to the frequency because you have a 2 pi FL, 2 pi FC. So if you adjust the value of the frequency here, so the value of XC or the value of XL may be changed, but not for the resistor R. Right? So that's all. Thank you.